Hello and welcome back. Let's solve the Leetcode 131 Palindrome partitioning. So the problem is given a string as partition as such that every substring is a contiguous non-empty sequence of characters within a string. Okay, such that every substring of the partition is a palindrome. Okay, a string that reads same forward and backward. Okay, we need to return all possible palindrome partitioning of S. Okay, so for example, we have AAB. Our output will be two partitions, right? A, B, and A, and B. Okay. Uh, with the constraint is the length can be up to 16 lowercase English letters. Okay. Okay, I think for this problem, since the constraints are quite the constraints the constraints of the length s is quite small, only up to 16 lowercase English letters. So I think our solution can be we will try to generate all partitions of the given string, and for each partition we will check for every substring in that partition. If if all of them are palindrome, it means that partition is a valid partition and we will add to the output. Okay, right. So the main problem now is how can we generate all possible partitions for the given string s. Okay, well, yeah, for example, if we have the string s is AAB, okay, and uh, how can we generate all possible partitions for this given string? Okay, well, um, we we notice that for the for a string we always have two power of n minus 1 possible partitions, right? So where the n is the length of the given string s. Okay, so for this for example, in this example we have s is AAB. It means we will have 2 power of 3 minus 1, which is 4. We will have 4 possible partitions of the string s. Okay, let's try to generate all of them. We will have A, right? A and B. Okay, that is one, the first partition. The second will be A and B, right? Okay, and the third will be A and AB, right? And the fourth will be the whole string, which is A and B. Okay, and if we can generate all partitions like this, we will need to check for every substring in each partition if they are palindrome or not. For example, this partition is a valid one, right? Because A is palindrome, is palindrome, and B is also palindrome. Okay, this partition is also valid, right? A is palindrome and B is palindrome, right? And but for this partition, it is an incorrect partition, right? Because A is palindrome but AB is not palindrome. Okay, so we won't add it to the final results. And for the fourth partition, it is an invalid one, right? AAB is not palindrome. Okay, and so our output will be AAB and AA and B. Let's check. AAB, AA and B, yes, correct. Okay, and okay, let's think about the solution to generate from the given string to this yeah, generate from the given string, uh, generate all possible partitions of the given string S. Okay, and okay, so for me I will guide you using the bit manipulation to generate for these partitions. Okay, how? Okay, let's okay, let's represent all numbers starting from 0 to the numbers of partitions minus 1. It means if we have 4 partitions, right, we will represent 4 numbers starting from 1, 0, 1, 2, and 3. Okay, and for each number we will represent it as the binary. For example, 0, it means 0 and 0. Okay, and 0, right, because our length is 3, so we will represent it as 3 binary digits. For 1, it means 1 sorry, 0, 0 and 1. 2 is 0, 1, 0, and 3, 0, 1, 1. Okay, and okay, and we notice that let's assume that if 1, it means we will have an edge to connect between we will think for every single letter is a node of a graph, and if we have 1, it means we have an edge to connect between them. For example, if 0, we have 0, 0 and 0, right, it means from A and A it doesn't connect each other, right? A and B, it doesn't connect each other as well. Okay, okay, so it means we have the first partition. Okay, for the second partition, okay, we have A and B. Okay, so from A and A, okay, I think we don't need the first digit. I think we only need 2 digits, right? It means we only need to generate 2 binary digits. It means s dot length minus 1. Okay, 0, 0 means from A and A doesn't connect each other. A and B doesn't connect. Okay, so A and A doesn't connect, but A and B is connect, right? So we will have another partition is A and AB, right? Okay, and 1, 0, okay, we have A and B again, right? And 1, 0, it means A and A connect each other, right? And A and B doesn't connect, right? So we have another partitions which is A and B. Okay, and same with 1, 1, it means A and A connect each other, A and B also connect each other, so we have the final partition is A and B, right? Okay, that's the way we will use the bitmask to generate for all possible partitions of the given string S. Okay, and once we have this partition, we can easily to check for the palindrome, right? To check palindrome is very simple, right? We will keep track of the two pointers starting from the beginning and the end of the string, and we will try to increase the left pointer and decrease the right pointer when they are equal each other. And if we face if we see that the character as the left pointer is not equal to the character at the right pointer, so we will break. Okay, so that's all for the idea. That's all for the idea. And okay, let's go back and try to implement it. Okay. 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 First of all, let's declare for the results. Let's okay now array list, and finally return answer. Okay. We will have a variable for the length as dot length -1, and we will have a variable for the number of partitions will be one shift left length, right? That is the one shift left, it means 2 power of n minus 1. Okay, and we will have a for loop. We will have a for loop from 0 to the total number of partitions -1. Right, it means for in bitmask starting from 0, bitmask less than num of partitions, bitmask plus plus. Okay, and for each bitmask we will try to generate their partitions, right? So let's declare a list of string partitions equal to new array list. Okay, and we will do the for loop to generate two binary digits, right? It means from for in position starting from 0, position less than length, and position plus plus. Okay, so we will get the current bit. To get the current bit, right, get the current bit at the current position, we have the formula is bitmask right shift positions and with 1. Okay, and we will have a string builder temp. Okay, and if bit is 0, okay, bit is 0, we will okay, first of all temp append s dot char at 0, right? Char at, oh yes, correct, 0, because we always append the first letter to the substring, right? And Okay, if bit is 0, 0, it means it doesn't connect. Alright, so we will add to the partitions like partitions dot add temp dot to string. Okay, and reset the temp. Okay, then append the s dot char add position +1. Okay, else we will append the s dot char add the position +1. Okay. So okay, we will add the partitions. We'll add temp dot to string to the partition. Okay, and okay, let's temporarily add partition to the answer array to check for the corrections of the generation first. Okay, and okay, let's try. Oh. Okay, it should be here. Alright. No. Oh no. Okay. Okay, so we are successfully generate all possible partitions for a given string. Okay, so the next step is we will need to check. We will filter out all possible palindrome partitions, right? Okay. Okay. Let's do that. Okay, let's declare a method to check for the palindrome is palindrome string as left 0 right s dot length -1 y left less than right if s dot char at left is not equal to s dot char at right, we will return false. Return false, else we will increase the left pointer and decrease the right pointer. Finally we can return true, right? Okay, and we have list of string valid will be we have oh no, it's correct. Okay, list of string valid will be we have partitions dot stream dot filter as that is oh no, right, if one substring is not palindrome, so it means the whole partition will not consider as the valid, right? Okay, okay, if that's the case, let's implement like this. Okay, for string okay, substring in partitions if not is palindrome substring. Okay, we will Okay, another variable is current partition valid equal to true. Okay, and is current partition valid is set to false. Okay, unbreak it. Okay, else we will add to the valid dot add substring, right? And finally add to the valid. Okay. Oh, is nevertheless valid true if it is false. False, so we break and we so still a no, is valid if it's not palindrome. Okay, okay, if is current partition valid, so we will add to answer. Okay, accept. But I think here we do have a point that we can try to do to improve a little bit the performance. Okay, as you can see in this partition we have the substring is b, and for this partition we also have the substring is b. It means we will keep repeating the check for each palindrome multiple times, even for the same substring that we already checked previously. Okay, so it's unnecessary, right? Okay, so to improve the performance, I think we can add on the palindromes that we found to something like a cache, and then we can check if that string already exists in the cache. So it means uh, it's already a valid uh, palindrome substring, and we don't need to check for this method. So it can improve a little bit performance. Okay, let's try it. Set string cache new hashes. Okay, and if okay, so we will add a cache dot add substring. Okay, and okay, so we will check from the cache hash set string. Okay, no, not hash set, but set is enough. String cache. Okay, if cache dot contains s, so we can return true, and it's palindrome cache and substring. Okay, again. Okay, so now let's submit. Okay, accept.